Today we will discuss about one of the chapter of module 1 of your paper Chemistry 1. Under paper code BSCH 101 for first semester and BSCH 201 for second semester student of BTech course. In this chapter of electrochemistry, basically we discuss about the properties shown by different electrolytes. Especially in this chapter, we will discuss about the principle and construction of galvanic or voltaic cell. All of us know we cannot create or we cannot destroy any energy. We can only transfer the energy from one form to another form. In galvanic or voltaic cell, we try to generate the electrical energy from chemical energy. That means in this cell, chemical energy will be transformed into electrical energy. Today basically we will discuss about the principle that how can we convert this chemical energy into electrical energy. The principle behind this was proposed by galvanic and the cell was designed by voltaic, and that's why this cell is called galvanic cell or voltaic cell, where basically chemical energy is transformed into electrical energy. All we know the two familiar term oxidation and reduction. Oxidation means loss of electron and reduction means gain of electron. Again, all of us know that oxidation and reduction occurs simultaneously. So both one will occur at a time. There are basically two reactions: oxidation where the substance loses electron and the reduction where the substance accepts electron. Galvanic observed that when in a container of copper sulfate, a rod of zinc was placed, there occurs the deposition of copper over the surface of zinc. How it happens? Basically, copper 2 plus ion in presence of zinc rod is reduced into copper, whereas the zinc loses 2 electron to get into zinc 2 plus. So basically zinc is oxidized and copper is reduced. So there are two reactions, one is the reduction, another is the oxidation. Let us try to separate these two reactions. Why? Because when we keep this zinc rod in the solution of copper, the zinc and copper 2 plus are in contact with each other. Zinc loses 2 electron and copper accepts this 2 electron, and this exchange of electron happens inside of the solution. By the way, we cannot sense this exchange of electron outside in outer circuit. So basically we are trying to separate these two reactions in two different places. To do that, let us take two containers. In one container, let us choose a solution of zinc sulfate, which is having zinc 2 plus ion. Another container, let us take there the aqueous solution of copper sulfate, means the solution having copper 2 plus ion. In zinc sulfate solution, let us place a rod of zinc, and in copper sulfate solution, let us place a rod of copper. When we place zinc rod in the solution of zinc 2 plus, there will be the equilibrium between zinc and zinc 2 plus. Zinc is oxidized into zinc 2 plus by losing 2 electron. Parallelly, zinc 2 plus accept this 2 electron to get into zinc. What is happening over here? In a similar manner, copper 2 plus is there in the solution, which is reduced into copper by taking 2 electron. At the same time, it may happen that copper going to lose 2 electron to get into copper 2 plus. And this type of exchange of electron is taking place at the surface of that metal rod and the solution. It is observed that if we connect these two metal rod by some metallic wire, and if we check with voltmeter or ammeter, we can find there is the flow of current. It means that there must be certain way that the electron is flowing from one side to other side. Now what is happening there? When we place zinc rod in the solution of copper sulfate, we observe that copper 2 plus is reduced. So if we have zinc and copper in contact with each other, zinc has the tendency to be oxidized first and copper has the tendency to be reduced. In similar manner, when the zinc rod is placed in the solution of zinc 2 plus, zinc has the tendency to be oxidized by losing 2 electron. And this 2 electron flows through this metal wire and reaches at the copper rod, and where the copper 2 plus from the solution accept that 2 electron and reduce to copper 0. By the way, there is a flow of 2 electron, and that is detected by ammeter or voltmeter. Now we will see that after the deflection in the ammeter or voltmeter, we will not see any further flow of electron. Why it happens? Let us try to explain it. When we took zinc sulfate solution, there is having zinc 2 plus and also sulfate 2 minus. When we took the zinc sulfate solution, let us assume there is a 10 sulfate 2 minus, and obviously there is the 10 zinc 2 plus. That means the solution is basically electrically neutral. But when zinc losing 2 electron comes into the solution as zinc 2 plus, there will be the 11 number of zinc 2 plus instead of 10. Why? Because from the surface of the zinc rod, one zinc atom losing 2 electron coming as zinc 2 plus. That's why the number of zinc 2 plus ion in the solution is increased to 11. But in that place, 10 number of sulfate minus is there. That means initially the solution was supposed to be neutral, but after passage of one zinc 2 plus ion in the solution becomes positively charged. And when the solution will become positively charged, it will be very difficult that the second zinc 2 plus will come in the solution by losing another 2 electron. Otherwise, we can say that zinc will not come as zinc 2 plus by losing 2 electrons, since this solution is already positively charged. Now you come in the right side. If we see here, as usual, we can say that there was initially 10 number of copper 2 plus and 10 number of sulfate 2 minus. That means the solution was neutral. Now when this 2 electron was flowing through this circuit and reaches to this copper rod, there what happens? This copper 2 plus accepts 2 electron to get into copper. By the way, instead of 10, there will be the 9 number of copper 2 plus. But sulfate as it is, there is the 10 number. So there is the excess number of sulfate ion, which will make this solution negatively charged. And that's why When the another electron will try to come over here, it will be repelled strongly by this negative charge. In turn, we can say that there will be no further flow of electron. Why? Because the solution number 1 becomes positively charged and solution number 2 becomes negatively charged. Then what is the solution of it? Solution is that generation of the charge restricts the further flow of electron. So we have to stop the generation of charge. This is a simple solution. Since it becomes positively charged, you add there some negatively charged. Since it becomes negatively charged, you add there some positive charge. But all of us know we don't have the solution of positive charge, negative charge in the separate manner. We have only the different salt, which is the combination of both positive charge and negative charge. Then what is the solution for it? We have to take a U-like tube within which we choose some salt. Any salt you can't use, you have to use that type of salt having cation and anion which are having almost similar velocity or similar mobility. So for example, let us consider KCl. In KCl, K plus and Cl minus having the similar speed, and that KCl is mixed with some gel like agar-agar. This agar-agar is mixed with KCl and this U-like tube is packed. Then you place between these two solutions. What will happen then? Once one zinc from the surface of this zinc rod will come in the solution as zinc 2 plus, the solution will become positively charged. And suddenly what will happen? It will drag the Cl minus ion from this solution. It will drag some Cl minus ion from this solution. And since Cl minus ion will come in the solution, this positively charged solution will be neutral. And when there is a negatively charged solution, obviously it will attract the K plus from the solution to make it neutral. So once it becomes positively charged, spontaneously there will be the passage of negatively charged ion, that means Cl minus. When this solution becomes negatively charged, there will be the spontaneous flow of K plus into the solution to make both the solution neutral. Once the solution becomes neutral, there is no problem for further migration of another zinc 2 plus from this zinc rod by losing 2 electron, and this 2 electron again will continue to flow and will reach to the surface of this copper rod, where the copper 2 plus from the solution will be reduced by taking that 2 electron, and this process will continue. So this is the basic principle of galvanic cell or voltaic cell. So as a whole we can show you. So this is the two container. These are the two container. This container 1 having zinc sulfate, container 2 having copper sulfate, and in zinc sulfate solution we have placed zinc rod. In copper sulfate solution we have placed copper rod, and that is connected by some metal wire, and there is a U-like tube that is called what? Salt bridge. This is called salt bridge. Salt bridge is used to complete the circuit, and also it is used having that salt, like say for example K plus and NO3 minus. When there will be the migration of zinc 2 plus ion, nitrate will come in the solution to make the solution neutral. When K plus will migrate in the solution of this solution will become neutral. So by the way, periodically both the solution will become neutral and there will be the continuous flow of electron, so we can get some current. Now in the zinc sulfate pair, what is happening there? There is the reaction of oxidation. Which is oxidized? Zinc is oxidized by losing 2 electron into zinc 2 plus. And the compartment where the oxidation takes place is called what? Anode. In the right hand side there is the reduction. Which one is reduced there? Copper 2 plus is reduced by taking 2 electron into copper, and the reduction half is called what? Cathode. So basically this cell is divided into two halves. This cell is divided into two halves. Each half is called what? Half cell. Each half is called half cell. The half cell written in the left side is called left hand electrode. The half cell which is written in the right hand side is called right hand electrode. But arbitrarily you cannot draw anyone in the left side, you cannot draw anyone in the right side. There is the convention. What is the convention? You have to draw that one in the left side where the reaction will be oxidation. You have to draw that one in the right side where there will be the reaction of reduction. If there is the reduction, then we say that electrode as cathode. If there is the oxidation, we will say the electrode is anode. So this is the convention to represent this cell. In this cell, what is the total reaction taking place over here? Here we see zinc is oxidized, and here we see copper is reduced. So basically it is a very important application of oxidation reaction and reduction reaction. So we have to choose such a reaction which is spontaneous in nature. You cannot choose any reaction, but you have to choose such redox reaction which should be spontaneous. And you know that to be spontaneous, delta G term should be negative. Once the delta G is negative, the reaction will be spontaneous. If that is spontaneous, we can have some source of energy. What source of energy? We can have some chemical energy. And this chemical energy, once we get, will be transformed into electrical energy. So this is the basic principle of galvanic cell or voltaic cell, which was proposed by Galvanic initially. Now if we want to represent this cell, we have some convention. What is the convention? By convention we represent the solid bridge using a parallel line. Parallel line indicates it is a solid bridge. At the right side we used to draw right hand electrode. In the left side we used to draw left hand electrode. This right hand electrode is also called cathode, and the left hand electrode is also called anode. There are the different substrates at anode as well as at cathode, and having their different oxidation state. When we are going to represent the right hand electrode, you write the higher oxidation state of the substrates, followed by lower oxidation state. Say for example, if we consider this right hand electrode where there is the ion copper 2 plus and the metal copper, the higher oxidation state means copper 2 plus, where the copper in its plus 2 oxidation state. Then what we will write there? Copper. You see here is the state plus 2. What is the state over here? 0. 2 and 0, 2 is the higher state and 0 is the lower state. When we are going to write the right hand electrode, you write the oxidation state which is higher first, followed by lower. And reverse is the case when we are going to represent the anode. So for this example, there is the species zinc 2 plus which is the higher oxidation state and zinc which is the lower oxidation state. In case of anode, we have to represent the lower oxidation state first, followed by higher oxidation state. Thus, if you want to present the cell, finally what we should write, we will draw a parallel line which indicates the presence of solid bridge. In the left side there will be the anode. Anode means we have to write there the lower oxidation state, which is zinc here, followed by its higher oxidation state, that is the zinc 2 plus. And if we come to the right side, It is the copper 2 plus, which is in higher oxygen state, then copper, which is the lower oxygen state. And these slash used to represent that those species are in different phase. The species are in different phase. So for example, here copper used here as the solid, whereas the copper 2 plus present they are in liquid phase or say aqueous phase. Zinc here in solid phase, and zinc 2 plus present they are aqueous phase or liquid phase. So by the way, in brief, we can write or we can represent some galvanic shell or voltaic cell. So as we have discussed, we need to have the solve bridge. For what purpose the solve bridge is used, it is mentioned over here. Already we have discussed about the presentation of the galvanic shell. You see here where it is the place of anode, it is the lower oxygen state followed by higher oxygen state. Where it is the case of cathode, it is the higher oxygen state followed by lower oxygen state. And which one is the anode? You see here, anode means lower oxygen state followed by higher oxygen state. Which one will be the anode? Obviously, already we have mentioned where there will be the oxidation. And obviously, if there is the reduction, that is called what? Cathode. But when we make a list of some electrode, when we will make some list of some electrode, by convention, every one is presented as right hand electrode or cathode. There are two electrodes, one is cathode and one is anode, but when we are going to write a single electrode, then by convention we have to write that electrode as cathode. Cathode means among the substance involved we have to write the higher oxygen state followed by lower oxygen state. This is the convention. How to write cell reaction? Suppose you have been given some reaction and you will be asked that how to present that cell. Let us consider. So one reaction is given. So you have been given this reaction and you have been asked that you represent the corresponding cell. To represent this cell, first we have to understand that which one is being oxidized and which one is being reduced. And it is clear from here that here zinc is oxidized and H plus is reduced. All of us know reduction occurs at a right hand electrode, means cathode, and oxidation occurs at left hand electrode, which is basically called what? Anode. So first we have to choose the pair which will constitute anode and which will constitute cathode. Then all of us know we have to use some solve bridge, and solve bridge is normally presented by using parallel line. The right side of it will draw the right hand electrode. Which pair constituting the right hand electrode? Where there is the reduction, which is that H plus and H2. This is the pair constituting the cathode or right hand electrode. When we are going to present the cathode, we have to first mention the higher oxygen state, that is the H plus, followed by lower oxygen state, that is the H2. Now you come to anode. When it is the case of anode, first we have to write the lower oxygen state, which is the zinc over here. Then we will write its higher oxygen state, that is the zinc 2 plus. So this is the way to represent this cell where the given reaction occurs. Okay. Next one. Now we may be given a list of electrodes and you may be asked that to construct certain cell. Then how do we know that which one or which electrode will be taken as the right hand electrode or which one will be taken as the left hand electrode? There is some principle we have to know about it. What is the principle? Among the two electrodes which has the higher reduction potential, we have to use that as right hand or cathode. Among the given two electrodes, the one which has the higher reduction potential will be taken as cathode or right hand electrode, and obviously the second one will be taken as anode. So if you are given two electrodes, first you check that what is the reduction potential of those electrodes given. Then among the two given electrode, which one having the higher potential, the higher reduction potential, you use that as right hand electrode or cathode, and second one you use as left hand electrode. Now what is mean by reduction potential? Reduction potential is simply the tendency of any substance to consume electron. In simple word, what is the tendency or what is the capacity of that species to consume or accept electron? Reduction potential high means it has the higher tendency to accept electron. Reduction potential low means it has the lower tendency to accept the electron. So among the given two electrodes, which one having the higher reduction potential, that will be taken as the right hand, and which one will be the electrode of lower potential will be taken as the left hand. So basically in the cell we have two electrodes, right hand or cathode and left hand or anode. For a given cell, we used to define another very important term, that is the EMF, which is normally noted as capital E. For a cell, if we say for a cell, E cell is nothing but the difference in reduction potential. Remember this is the difference in reduction potential. Now difference means A minus B is the difference, B minus A also is the difference. Again there is the convention which comes to act. By convention we have to take the difference of the potential of right hand electrode minus of left hand electrode, not the difference, left hand minus right hand. By mathematics A minus B is the difference, B minus E also the difference, but as per our convention we will take the potential of the right hand electrode first, followed by left hand electrode, their difference. Now what type of potential? It is the reduction potential. What type of potential here? It is the reduction potential. Remember it, in left hand oxidation occurs. In left hand or anode oxidation occurs. Then too, by convention we have to take what? Reduction potential of both the electrode, though oxidation occurs there in left hand electrode. Remember it, again I repeat, it is the difference of reduction potential, and it is the right hand reduction potential minus left hand reduction potential. Left hand electrode, what is the reaction there? There is the reaction oxidation. Then too, by convention what to do? We have to take the reduction potential. This is a very important thing you have to remember, that we have to take the reduction potential difference, not left hand followed by right hand, rather right hand followed by left hand. If we want to get current, E cell must be positive. If you want to get current, E cell must be positive. And just now we have written that E cell equal to E RH minus of E LH, where both the term is the reduction potential. And since it is positive, so mathematically it should be the case that right hand electrode potential should be greater than left hand electrode potential when you are considering the reduction potential. At beginning we told that between the two electrodes given to us, which one will be taken as the right hand, and obviously which one having the high reduction potential will be taken as the right hand. In that case only E cell will be positive. If E cell is positive, then only we can get some current from that cell, otherwise not. Now question comes, if we are given the electrode potential, from that data we can decide that which one will be taken as the right hand or cathode and which one will be taken as the left hand or anode. So first thing is that you have to know the potential, then only you can decide it. Now let us try to discuss that how can we get the potential of those electrodes. Which potential we are discussing about? Basically we are discussing about the reduction potential. How can we measure the reduction potential? How can we measure it? Before we discuss it, we have the query, can we measure absolute value of standard reduction potential? We have used one term here, standard. Standard means substance in a standard state. By standard state, we usually choose 25 degrees centigrade as temperature and 1 atmosphere as pressure. In that condition, the reduction potential, whatever its value, is called what? Standard reduction potential. Can we measure the absolute value of it? Answer is no. You can't measure it. What we can do? We can only measure the relative potential. We can only measure the relative potential. So, since we are trying to get the relative value, we have to have some reference. What is the reference we used to take? We used to take the hydrogen electrode as a reference. We used to take the hydrogen electrode as reference. If any electrode, say for example Mn plus M given to us, for this we want to find out its potential. What to do? You have to first construct a shell on combination with hydrogen electrode. But which one will be right hand and which one will be left hand? We do not know. Then what is the way? We will choose arbitrary manner. Say solid will be there as usual. You place M N plus M, that is the electrode potential of which is to be measured out. Say at the right side, means we are going to treat that as right electrode. And then you consider the hydrogen as left electrode. Then you check using ammeter or voltmeter that electron is flowing or not. If electron is flowing, that means the electrode right hand or electrode left hand what you have selected, that was right. And if you don't find any flow of electron, then you have to sense that whatever we have selected that is not right, you have to interchange this. So for example, we have taken this one as the correct pair of electrodes. So basically by combination of the unknown electrode, potential of which is not known, and hydrogen electrode, you have to construct a shell. For this shell, we will try to find out the potential under standard condition. Standard condition means for hydrogen electrode, H plus should have the concentration 1 molar. For hydrogen gas, its pressure should be 1 atm. If it is the case, that is called what? Standard hydrogen electrode. Mn plus, it also will have some concentration. How much concentration it would be? It should be 1 molar, because we are going to consider standard state. If M is the metal, that must be in solid state. This is the standard condition. Under this condition, you construct that cell. What is the next? After construction of that cell, you try to find out the cell EMF. Try to find out the cell EMF. Cell EMF, already we have written E cell equal to reduction potential of right hand minus left hand. Right hand means here it is Mn plus M minus H plus H2. For this one, say E cell, you will get some value, say X, but its value we are trying to find out. Its value we do not know. What condition we are using? We are using the standard condition. We are using the standard condition. To mention the standard condition, we used to use 0 over here. This X parameter is measurable, but we do not know about this parameter. We do not know about this parameter. Again, we have mentioned that absolute value we can't measure. And what is the simple manner to detect it? We use some reference hydrogen electrode, potential of which is taken as 0. So thus we can say that X equal to E naught M N plus M minus 0. To make our calculation simple, we used to use the value 0. Thus E naught M N plus M will come as equal to X. So by the way, you can have the value of this potential. What is the condition we have, or what is the assumption we have used here? Potential of hydrogen electrode is 0 under standard condition. What is the standard condition? Hydrogen should be at the pressure 1 atm and H plus should be having concentration 1 molar. Under this condition, you can find out the E naught value of any electrode. So by the way, whatever the potential we used to report, all are relative value, no one is the absolute value. Relative to which one? Relative to hydrogen electrode, we used to define the potential. So that potential normally we are reported in the form of electrochemical series. From there, among any two electrode, which one having the higher potential, you place that at right hand side as cathode, and which one is the left hand side, that should have the lower potential. By the way, you can construct a cell, and we have mentioned here that under standard condition, that is the potential. So obviously always we will not be able to maintain the standard condition, and what would be the potential in that condition we should know, and we will discuss that in our next class in the form of Nernst equation. So basically this equation we will use to find out the potential of any electrode when the substance which will be used are not under standard condition. So with this discussion we will end our discussion today, and in the next class we will discuss about the application of Nernst equation.